Now let's try some reconstitution problems. Let's look at our first problem. The doctor orders Librium 25 milligrams IM every 6 hours as needed. The directions on the label read, add 2 milliliters special diluent to yield 100 milligrams per 2 mLs. How many mLs of medication should be given? Well, as we can see on the label, after this medication is mixed, the solution will result in 100 milligrams per 2 mLs. That's the dosage strength that we're looking at. We know the relationship of 100 milligrams in every 2 mLs. The doctor ordered 25 milligrams, and we need to find out how many milliliters to administer to the patient to deliver this amount of medication. We can do this by multiplying our means and our extremes. 100 milligrams times x ml equals 2 ml times 25 milligrams. To get x by itself, we divide both sides by 100 milligrams. And we discover that 2 milliliters times 25 divided by 100, we are going to have to give 0.5 milliliters. Another way to perform this calculation is through the use of the proportion method. We need to look at a fractional equivalency between the dosage strength and the method that we're giving it in this case, milligrams and milliliters. We can see according to the label that after this medication is mixed, it will deliver 100 milligrams in every 2 milliliters of medication. The doctor ordered 25 milligrams, and we need to find out how many milliliters we need to give to deliver that medication. We can solve this proportion by using cross multiplication. 100 milligrams times x mLs equals 2 mLs times 25 milligrams. In order to get x by itself, we need to divide both sides by 100 milligrams. We can now see that x milliliters is equal to 2 times 25 divided by 100, or 0.5 milliliters. Third way we can do this calculation is through the use of dimensional analysis. In this case, we're going to start with the doctor's order of 25 milligrams. We're being asked how many milliliters we need to give. Therefore, I want to look for a relationship between milligrams and milliliters. I'm going to put milligrams at the bottom and milliliters at top so that milligrams will cancel and I'll be left with milliliters. I can tell from the bottle that after this medication is mixed, it will deliver 100 milligrams for every 2 milliliters of medication. Milligrams now cancels, and when we multiply 25 times 2 and divide by 100, we see we need to give 0.5 milliliters. The last method we can use is the formula method. In this case, we take the doctor's order of 25 milligrams, divide by the dosage on hand, 100 milligrams, and multiply by the quantity it's being delivered in, 2 milliliters. Milligrams cancels, leaving us with the unit milliliters, and when we multiply 25 times 2 and divide by 100, we end up with 0.5 mLs to be administered. Let's look at another one. This time we have an order of 250 milligrams IV every day for 5 days. We can see the label reads 1 gram. It tells us that for a single dose use, we're going to add 50 milliliters to this 1 gram, shake it, and dissolve the drug. We need to know how many milliliters to give the patient every day. Well, because this is a single dose use, we know that 1 gram is equivalent to 50 milliliters. The doctor ordered 250 milligrams. Therefore, instead of using 1 gram, we're going to have to convert that into milligrams, and we should know that 1 gram is equivalent to 1,000 milligrams. We can now set up a relationship between milligrams and milliliters. We know that 1,000 milligrams is equivalent to 50 milliliters. we need to give 250 milligrams, and we need to know how many milliliters that will be in. We then can multiply our means and our extremes. 1,000 milligrams times xml equals 50 milliliters times 250 milligrams. To get x by itself, we have to divide both sides by 1,000 milligrams. On the left-hand side, the 1,000 milligrams cancel out. On the right-hand side, the units milligrams cancel. We then can multiply 50 milliliters times 250 divided by 1,000, and we discover we need to give 12.5 milliliters. We can also use the proportion method to solve this problem. Again, the order is in milligrams and the label reads grams. Because this says 1 gram, we can simply just change 1 gram to 1,000 milligrams. We know that these two are equivalent to each other. We then can set up a fractional relationship between milligrams and milliliters according to the label. We can see that there's 1,000 milligrams in every 50 milliliters. The doctor ordered 250 milligrams, and we're looking for the equivalent amount of milliliters. We can solve this proportion by using cross multiplication. We have 1,000 milligrams times xml equals 50 milliliters times 250 milligrams. To get x by itself, we have to divide both sides by the 1,000 milligrams. This leaves us with x milliliters by itself on one side, and 50 milliliters times 250 divided by 1,000 gives us 12.5 milliliters. Third method we can use is dimensional analysis. This time we'll start with the doctor's order of 250 milligrams. As we want to deliver this medication in milliliters, I know I'm looking for a relationship between milligrams and milliliters. When we read the bottle, we can see that it says 1 gram is equivalent to 50 milligrams. However, since we need milligrams, we're going to change that 1 gram to 1,000 milligrams. Now we know that there's 50 milliliters, and each 50 milliliters contains 1,000 milligrams. The units milligrams cancel and it leaves us with milliliters. When we perform the operations, we see that 250 times 50 divided by 1,000 gives us 12.5 milliliters. The final method to do this calculation is the formula method. We will put the doctor's order of 250 milligrams. We need to divide that by what's on hand. As you can see from the problem, it's giving us the label in grams, so we're going to want to change that to milligrams so that it matches our order. We know by definition that 1 gram is equivalent to 1,000 milligrams. Therefore, our order is 250 milligrams. We're going to divide by the dosage on hand, 1,000 milligrams, and multiply by the 50 milliliters it's being delivered in. As you can see, the milligrams cancel and we're left with milliliters. When we multiply 250 times 50 and divide by 1,000, we discover we need to give 12.5 milliliters.